Good afternoon, folks. So, I've slam dunked that the moon does not affect the tides on this planet. Today, I have been trying to prove myself wrong. I have looked for reasons that will prove that I am wrong, right? I can't. How would you prove that the moon is not moving the tides on this planet? First of all, let's not forget something, okay? It's the distance away from us that it is, and it's orbiting near the equator, okay? So it doesn't matter what anybody says on this one. It is not logical for the higher of the tides to all be up here. It just isn't logical. Even your average Joe should understand this, okay? So I'm going, what? How? King tides. We get a king tide in December. King tide. It's a freakishly higher tide than usual. So, yeah, the king tides usually happen twice a year, right? It says. I'm trying to prove myself wrong. Keep searching, looking through loads of yeah, but king tides sometimes happen 4 and 5 times a year. Straight away. That doesn't make sense. Now another thing with that, if there is a king tide somewhere, there is a certain amount of water on the planet. Surely that means somewhere is getting a freakishly low tide. But I cannot find anywhere that it says, oh, what would it be? A princess tide maybe. A king tide and a princess tide. Not a queen tide, she'd be in between. There's no sign of any princess tides happening anywhere when there are king tides happening. So where is that extra water coming from if it's not missing from anywhere? I have been trying to prove myself wrong. The distance that the moon orbits planet Earth, it's a long way away, right? It's orbiting Earth around the equator. So the highest tides would be, using logic and common sense, along the equatorial regions, okay? But it's not. We're not moving any other bodies of water on this planet. Even though it should be, like the Mediterranean Sea, etc., etc. Then, my own observations again, I have the moon right up there, and it's low tide here. But there are times when the moon is up here, and it coincides with a high tide. So again, how does that work? I have been trying to prove myself wrong. Where is the logic in there being a high tide when the moon is... No, sorry. Where is the logic in witnessing a low tide when the moon is right above me here in Australia, but it's low tide? Why? How does that happen? But then there are times when the moon is above us and it's high tide. So straight away, something isn't synchronized, is it? It can't be. So does that not tell people, the people who say, yeah, but the tides coincide with the moon and stuff? But it doesn't. It It doesn't, does it? If it coincided with the moon, where the moon is at, you would, look, even give or take half an hour, but it's not like that. It doesn't matter where the moon is in its orbit around the Earth for when the tides are high and low, right? It doesn't matter. So I'm still trying to prove myself wrong. What else is there? The rogue waves. Rogue waves. How does a rogue wave happen? We're talking the waves that come out of nowhere and knock ships over, right? Now, we have tsunamis, bang, tectonic plates, poof, they shift. A tsunami is not a mountain of water, but it's high and long. It's like, it's water displacement. Bang, the tectonic plate has shifted under the ocean, poof, instantly the water just goes boom, or should I say, the tectonic plate rises and instantly pushes water up. You cannot compress water. The tectonic plate goes like that, bang, under the ocean. That water has got to go somewhere, and fast. It goes up. You have yourself a tsunami, but it has momentum behind it, right? A rogue wave is a wall of water that have been measured up to 33 meters high, right? We're looking at 100 feet. Where did that come from? Where did the rogue wave come from? You can't say storms and this and that, because sometimes they come out of nowhere when the weather is fair, right? So again, I'm trying to prove myself wrong here. But the more I'm digging, the more questions. Now here's the thing. I ended up, right? Oh, stop it, be quiet, laptop. Stop it. Right, I ended up right, where are we? Where are we now, right? Oh, I know, I'm sorry. What does it say? This NASA image from the Apollo 8 mission shows the Earth viewed over the horizon of the moon. While the moon and sun cause tides on our planet, the gravitational pull of these celestial bodies does not dictate when high or low tides occur. It's there in black and white. I'll read that again. While the moon and sun cause tides on our planet, the gravitational pull of these celestial bodies does not dictate when high or low tides occur. All right, now straight away, listen, if the moon and sun were creating the tides on this planet, we have a certain period of time it takes the moon to move around. The sun, it's where it is. You would be able to find a pattern, some kind of synchronicity in all of this. But there isn't. Now straight away, right? So here it is. I've been saying that no, they don't create the tides. And all of a sudden, after digging, trying to prove myself wrong, the gravitational pull of these celestial bodies does not dictate when high or low tides occur. So what dictates? Listen, tides originate in the ocean and progress toward the coastlines, where they appear as the regular rise and fall of the sea surface. Now this is where I just go, oh, here we go. Thanks to Sir Isaac Newton, 1687 discovery, we know that tides are very long period waves that move through the ocean in response to forces exerted by the moon and sun. However, these gravitational forces do not control when high or low tide events occur. Other forces, more regional than the moon or sun, control the tides. Many of them have to do with the geography and shape of the Earth. Now, so everything is suddenly out of sync. The shape of our planet has a lot to do with differences in gravitational pull at various locations. Here we are. If Earth was a true sphere covered by an ocean of constant depth, then it would be true that a high tide event would occur at the location with the moon overhead. The tidal bulge would move around the Earth with the moon, but this is not the case this is not the case with our planet. The Earth is not a true sphere, but bulges slightly at the equator. It is also dotted with large land masses, continents. Areas where the Earth's surface is higher, such as mountains, have a stronger gravitational force than do places where the surface is lower, such as a valley or cavern. At the same time, the depth of the world ocean varies greatly. All of these factors play into the height of the tides. Another thing to consider when thinking about tides is the dimension of time. These are lags in time when an observer experiences high or low tide, and the lag varies from one location to another. For example, the rising... I am going to stop there. I am going to stop there because for me, we have just reached fairy tale land. Now, I have been trying to prove myself wrong, and I find myself listening to something to do with variations in time and relative to the observer. Listen, the moon does not affect the tides on this planet. There is no gravitational pull from the moon on the water. And that, and listen, I have been trying to prove myself wrong. You heard? So the mystery continues, the plot thickens, variation in time. This is where I'm afraid my common sense and logic ring the bell on the bus. I'll get out at this stop. I'll let you guys continue with your idea of what common sense is and logic is, right? Because seriously, the moon has nothing to do with the tides, which straight away has to make you question gravity, doesn't it? All right, I'm being objective and I tried to prove myself wrong, but I can't. Not logically, I can't. All right, folks, I'll be back.